So we've literally just talked about the fundamental counting principle so far, where if we have parts that make up a whole thing, that we take those pieces and put how many options we have above and multiply them, right? So we're going to keep going with that. So here we have the telephone numbers allocated to subscribers in a rural area consist of one of the following. The digits 3, 4, 5, followed by any 3 further digits, or the digit 2 followed by the digits 1 to 5, followed by 3 further digits. Okay? How many different telephone numbers are possible? So we're going to have 2 cases. So you try it out. What would you do? 3, 4, 5, or, and whenever you see or, you're going to add, and then do your other case. So try that out. So we have the digits 3, 4, 5. You could have done it 2 ways. So one, some people just go 3, 4, 5, and that's one way. Some people go 3, 4, 5. And I have one way times one way times one way. Either way, if you say 3, 4, 5 is one way, it's the same thing, right? And then 3 further digits. So we have to deal with these ones first because they were restrictions. And here I could have 0 to 9, 0 to 9, 0 to 9. So 10, 10, 10, which is equal to 1,000. Exactly. Then or, so we're going to add that to the digit 2, followed by the digits 1 to 5, followed by any 3 further digits. So it's going to be 1, 5, 10, 10, 10. Which equals 5,000. Now, whenever you get cases, I could have this or I could have this. We always have to add the cases up. Okay, I have this many plus this many, and it gives me my total. So, if I go 1,000 plus 5,000, it equals 6,000. So we have 6,000 different telephone numbers possible. I'm going to get you to try example 9. It's like example 5, but I'm going to tell you right now that there's a trick when you have even 4-digit numbers with no repetition. There's a little bit of a trick. Okay? So make sure you maybe do it with pencil if you were intending on trying to do it in pen. So try this bullet and this bullet. So, this happened, but now we're here. Okay, so 0 is at the end, 2, 4, 6, or 8. Only happens when you have 2 cases where it's even, non-repeating. With odd, it wasn't an issue. So, when we have 0, we have one option, right? It's a 0. Then we box and hold that 0. Then we have 1 to 9. Which is 9 options. Maybe we hold the 9. Then we have 1 to 8. When we did odd non-repeating, I told you we had to remember to bring that 0 back, didn't we? But we've already used it up. So do we have to remember to bring the 0 back in this case? Nope. That's also why you can't lump the 0 with the 2, 4, 6, and 8. So I only have 8 options. Box the 8, 1 to 7. And I have 7. So that's if I pick a 0. What's 9 times 8 times 7? Does anyone have that? 504? What do we do when we have an or? Add. So you have 504 plus. Now we do the case where it's 2, 4, 6, or 8. So that's 4 options. Then I'm going to hold the 2. So now I have 1 and 3 to 9. Which is how many options? 8. Box the 1, then I have 3 to 9. So now I have 7. I actually have 8, because what do I have to remember to do? Bring back that 0, because we didn't use it here, and we didn't use it here, right? So we bring back our 0, and we have 8. Box our 0, we have 3 to 9, which is 7. What's 8 times 8 times 7 times 4? 1792. So we're going to go 504 plus 1792. 2,496. Do you agree? I did not line them up properly, so. There's no way. It's 2296. Right? I need to move this over. It'll be 6, 9, 12, 22. Yeah. 2,296. So before this, I told you, if it doesn't say you can't repeat, you assume that you can. Right? That was my thing. It says you can't repeat. If it doesn't say that, then you assume you can. This is the only place where people get errors. Because when they give you something like the word English, it won't say that you can't repeat, so people want to repeat it. But they literally just gave you the word English. That's it. So it's like on a Scrabble tile, they laid out the Scrabble tile, they laid the Scrabble tiles on it, and you have an E, an N, a G, an L, an I, an S, and an H. And that's it. You don't have like an infinite number of them that you can make up. You have the word English sitting in front of you on letter tiles. Okay? So when can you repeat? When they give you the word like pool. If they give you the word pool, you repeat it. You have 2 O's now to use, right? That's it. So with English, do I have any repeating letters? No. So can I repeat any of them? No. I have 1 E, 1 N, 1 G, 1 L, 1 I, 1 S, 1 H. If you can wrap your head around them looking like a Scrabble tile, these questions are really easy. If not, you'll try and repeat all the letters the whole time, and it just goes really badly. Okay? So, let's read the question. It says, consider the number of distinguishable. What does distinguishable mean? Something's distinguishable. What can you do? How can you tell distinguishable? Sorry. It's different. So this is different from this, right? For example, fool is different than loop. But now I'm going to swap the O's. Is it any different? No, these two aren't distinguishable, right? If I swap the O's, they still look the same. That's what that means. And it's not, they're not looking for specific words. They're not making you look it up and see if it's really a word. The word could be E-E-E-P. So it doesn't have to be a real word. It just needs to be distinguishable. So you have to be able to tell the difference. So they want the number of distinguishable 4-letter arrangements. Distinguishable 4-letter arrangements. So we're not arranging all the letters in English this time, just 4 of them. That can be formed from the word English. When given a word, it is assumed you only have the letters contained in that word the amount of times that they occur in the word. So I have 1 E, N, G, L, I, S, H. So determine the number of distinguishable 4-letter arrangements that can be formed from the word English if any letter can be in any position. So how many blanks are we going to have? It's a 4-letter word. How many blanks are we going to have? 4. Because in each of those blanks, always, I told you when using the fundamental counting principle, you can only leave one thing in each of those blanks. That's the rule of the fundamental counting principle. So if we're doing a 4-letter word, we're leaving 1 letter, 1 letter, 1 letter, 1 letter, right? So we're going to have 4 blanks. Now to make it actually visible, which you're not going to have to do this every single time you see one of these questions, but I'm just showing it to you so you understand what I'm saying. There's no restrictions. So for the first blank, I could have E, N, G, L, I, S, H, right? I could have every letter, couldn't I? So that's 7. Then I hold one. Say I hold the H. Then I'd have ENGLIS. So now I would actually have 6, right? Because I'm holding a letter there. Then say I hold the S. For the next blank, I would have ENGLI. So I would have 5. Then say I hold the I have ENGL, which is 4. Yeah?
Why would you hold it if you can have any letter?
Because we're holding it just so that we don't repeat it, but not saying that that's actually the letter that's being held. So I could have held the E, the N, the G, the L, the I, the S, or the H here, because I have the option to hold any of them. That doesn't mean that this word is actually Hasiin. Okay? It doesn't mean that that's the actual word, but that's just one of them that it could be. Okay? So the only reason why I'm holding one is just so that I can see that I'm actually going down by a letter. So you don't actually have to show these examples on the bottom. The key to the examples is just that you see, okay, I'm holding a letter here, I lost one. I now can only have 6 for this space. And then I'm going to keep a letter here, so then I'm only going to have 5 for this space. Keep a letter here, 4. So you could keep any letter you wanted. You guys are going to try B, C, and D. So for B, it says the first letter must be E, and that's the only restriction. So we still have 4 blanks because we need to have a number of distinguishable 4-letter arrangements. This one's going to be an E, which is one option. And then I hold the E, so how many letters do I still have left? 6, then 5, then, which I believe is 120. Okay. This one says the first and last letters must be vowels. And vowels in the alphabet are A, E, I, O, and U. In math, there's never a sometimes Y, because we're not trying to form exact words, right? Now, the thing that people don't know about, everyone's really good with vowels. There's 5 of them. Everyone forgets about this word. What's a consonant? Letters other than A, E, I, O, U. You guys know what vowels are, you just don't know what the word is called for a consonant. Okay? So sometimes consonant comes up, there's 21 of them. And then vowels, there's 5. So the first and, I know it doesn't say anything about consonants in here, but I know that's one that people forget about. So the first and last letters must be vowels. So we only have 2 vowels, they're E and I. So for this blank I would have 2, and then I would hold one of them there. So the back I would have 1. How many letters have I placed? 2. How many do I have left? 5. So 5 and then 4. So it's 40. Oh, I didn't put the answer to this one. What was this one? 480 or 840? The last one is the word must contain a G, but it doesn't say where the G has to be, correct? So the G could be in the first blank, or it could be in the second, or it could be in the third, or it could be in the fourth. If the G was in the first or in the fourth, it would make totally different words, wouldn't it? So we're actually going to have 4 cases. Or we're going to notice that it's going to move 4 times and we can multiply by 4. Those are our 2 options. So we could have a G at the beginning, or a G in the second one, or a G in the third blank, or a G in the fourth. Every time we say or, we're starting over. We have the word English back again, right? Because we're starting out with a whole new case. So here I have 1 for G, and then I have 6 letters left, 5, 4. Or I could have 1 for G, 6, 5, 4. Or 1 for G, 6, 5, 4. 1 for G, 6, 5, 4. Or you could say, hey, I know that each time it's going to be 120, correct? And then the G could move into 4 spots. So instead of adding up 120 4 times, I could say, okay, it's the 120 times 4, which is 480. Yeah? So first off, you don't get textbooks because you can't this week, but also, this is called 11.1 in your textbook, and 11.1 in your textbook is fundamental counting principle, factorial notation, and permutation. It like shoves a whole bunch into one lesson. So instead of you getting the assignment right now, you're going to get it a little bit later once you've learned all 3 of the parts to get that lesson. Because chapter 11 is 3 parts of your textbook. A lot of the textbook it has like maybe 3 lessons per unit. So we have to break the units out a bit because they're kind of crazy condensed. Okay, so I assigned 1 to 7, I believe. You're going to circle the rest for tonight. So I think, oh, I did 1 to 6, didn't I? So you're going to do 7 and 8, which is just 2 more for tonight. And then we're moving on to factorial notation right now. So factorial notation is when you can do rocket counting. So example was where you said is if we went 6 times 5 times 4 times 3 times 2 times 1, we could go 6 factorial, right? And 6 factorial is just 720. Or 6 times 5 times 4 times 3 times 2 times 1 is 720. So basically, if you can say blast off after you're done it's a factorial notation, right? So factorial notation is I started a number and I decreased by 1, multiplying until I get to 1, correct? So it can't be any negative numbers, obviously, and it can't be 0, right? Because it stops at 1. Do you agree? So, we are going to use, I'm still laminating these because I want you to have a laminated copy and it's labeled back ordered, so I want to laminate this for you. So you can just wipe it off after you're done, whatever. But this here is going to be the stuff we're going to use for this unit. And they even label it. But this is the actual formula sheet for your 30-1 diploma. So here it says n factorial equals n minus 1, n minus 2, 3 times 2 times 1. And these are the formulas we're going to use for permutations and combinations. So this lesson is not one where they're just going to give you this and ask you to solve it. Okay? But if you're ever asked to do it algebraically, this formula or this formula, we are actually doing this. Okay? So these are the steps so that when we get to use that formula algebraically, we can do it. So, n factorial in general is, we started an n, and then our next one would be 1 less. So n minus 1, then our next one would be 1 less. N minus 2, then n minus 3, till we got to 3 times 2 times 1, and then we'd be done, right? Because we have to work our way to 1. So, what we're going to start doing for factorial notation is we're going to simplify first. And then we're going to get to do some algebra, which you're going to enjoy because it doesn't have words in it, which gives you a little break from words for this unit. So it says, simplify the following. Leave your answer in product form. What's product? Nope. Multiplying. It's the answer to multiplying, right?
Having sums out.
Yes. Yeah. So your product is, they just want you to leave it in factored form. So don't go like expanding it by foiling like crazy. Okay? So, leave your answer in product form where appropriate. Do not expand. So, n plus 2 and n, which one is bigger? N plus 2 or n? Factorial. N plus 2. Because if I fill the number in for n, like 3, this would be 5 factorial, that would be 3 factorial, right? So 5 factorial would be bigger than 3 factorial, would it not? So what we're trying to do is simplify. So we're going to expand the bigger one so we can cancel off the smaller one. That's what we're going to do. So when we ever want to simplify these, we're going to figure out which one of them is bigger and expand that one until I get the smaller one. Okay? So I'm not going to expand the bottom. I'm going to expand the top because it's the bigger one, right? If I fill the 3 in, this would be 5 factorial, 3 factorial. Okay? So this equals. We're going to have equal signs every time we do expressions because you're saying that this equals the next expression equals the next expression. And to be honest, that's what profs complain about the most is that you guys don't have equal signs anywhere on your page. If anything, there's an arrow. Yeah? You don't, like the teeny, oh yeah, the actual question?
Yeah.
Is it fuzzy on there?
I don't have it on this.
It didn't show up?
No.
Oh, why? You can't just like, it's with imaginary ink. That's sad. Okay. Thank you. I didn't know it did that. I love printers when they don't print what they're supposed to. So it's n plus 2 factorial over n factorial. You can't read the like 6 fonts that's on this board right now. Oh, that actually is a good lead into. You have to be in alphabetical order as per the government, but if you can't see or you can't hear from where you are, you can tell me and I can move you. Like, you don't have to sit in this place if you're stuck and you can't see or hear. Like, if your learning is compromised because of where you are, I'll remove you. Okay? So make sure you tell me. So we have n plus 2 factorial over n factorial. N plus 2 factorial is the bigger one, so we're going to expand it. So we're going to start at n plus 2. Then what would be next? 1 less. So what would that be? N plus 1. So if I take 1 away from 2, I get n plus 1. What's 1 less if I take 1 off of there? Just n. Right? And then it would keep going, wouldn't it? N minus 1, let's say. Because that would be 1 less. I could do n minus 2 if I really wanted to. And then behind it, I could put a factorial at any point in time because it's just going to keep going, right? Because I don't actually have a number for that n. So on the bottom, I have n factorial, which I could write as n. What's 1 less than it? N minus 1. 1 less than that, n minus 2 factorial, and then I stop, right? And then these match, and I can cancel them off. But instead of going that far, would I have had to have gone that far? No, I could have stopped when the top matched the bottom, couldn't I? So I could have just went n plus equals, n plus 2, n plus 1, n, and I have an n factorial down here, right? N factorial, right? It was, I could stop there, and then they would have canceled off right away once they matched, right? I could have done that. Yeah, you want to show the factorial because the factorial is an actual mathematical term rather than the dot, dot, dot.
Yeah.
Now, I think this is the problem. I think they would give you the mark, but I don't know if they would. So I would rather know that they will. And with the factorial, you're proving that you're giving an actual mathematical term, and then they'll for sure. Right, and the factorial is found in the math textbook as what it means, right? So they'll go through and they'll make sure that when you're doing stuff, that it can be supported by something from the approved resource, which is the textbook. Okay, so we're going to get, I don't know, I'm ready to say, n plus 2 times n plus 1. And then I said to not expand. So you're done. With b, which one is bigger? N minus 2 or n minus 1? Factorial. Which one's bigger? Yeah. N minus 1. And if you don't know, fill a number in for n, like 6. If I fill 6 in, this is 4 factorial, this is 5 factorial. 5 factorial is bigger, right? So if you have to fill a number in, fill a number in. So I know that this bottom one is bigger, so I'm going to expand it and keep the top. So I'm going to rewrite the top, and I'm going to expand the bottom until it matches the top, because I'm expanding the bigger one. So I start at n minus 1. 1 less than that is n minus 2. And then I can put a factorial symbol. And the reason why I did that right away is I saw they match, right? And this is where errors happen. So these cancel off, and everyone tells me the answer is n minus 1. Is the answer n minus 1? No, the answer is actually 1 over, yes. So if you cancel off your numerator, you have to keep that 1. If you don't, you're telling me that I can do this. 1/6 of a pizza is actually 6 pizzas. That would be sweet, but that is not true. We are not making more pizzas out of this, okay? So if your numerator cancels, these little canceling things are actually ones. These little slices, whenever you're crossing off, you're being left with ones, right? When you simplify, those little slashes are ones. So on the top, I have 1. And on the bottom, I have n minus 1 times 1, which is n minus 1. So that's why I still have to keep that 1 up there, because that slash is a 1. If the 1 was in the denominator, would I have to keep it? No, because 6 over 1 is actually 6. That's good. You have to keep it in the numerator, though. Okay, here we have n, and here we have n and n minus 1. Well, it doesn't matter which one's bigger or not. There's only one of them with a factorial symbol, right? So I'm going to expand that one. So I'm going to get n, and one less than that is n minus 1. Now this is where the error happens. So people will stop here. Okay? If a and the catch is this one has a factorial. Don't do this. Just pay attention at this point. This one has a factorial, right? If I cross these all off, the only thing that's left with on the top is a factorial symbol. A factorial symbol without a number in front of it is an exclamation mark. It's not a math term. Because you have to have a number with an exclamation mark behind it in order to be a factorial symbol, correct? Because that makes you know that you start at that number times down by that, so 1. So I'm not going to stop here, because that would cross off and I'd have an exclamation mark just stuck at the top, which is just an exclamation mark, not a factorial. So I actually have to go one more. And I have to go one more because this one didn't have a factorial symbol, right? The previous ones all had factorials, so we could just cancel off that life was good. This one down here doesn't have a factorial symbol, so I can't cross it off. So I have to go one more, n minus 2 factorial. And now I can cancel an n for an n and an n minus 1 for an n minus 1. Because that's not an n minus 1 factorial in the denominator, it's an n minus 1. And so I'm left with n minus 2 factorial. Okay, we're going to look at algebraically solving this. N factorial, n minus 2 factorial equals 42. This is what's going to be asked of you. Okay? So what we've done is always, so far we've just done the left side, right? So we're going to expand that out first, always. So which is bigger, n factorial or n minus 2 factorial? N factorial. So we're going to expand it. So I'm going to get n factorial over n minus 2 factorial equals 42. And I'm going to expand that n factorial first. So I'm going to get n. 1 less is n minus 1. 1 less is n minus 2 factorial over n minus 2 factorial. And this time I could stop at n minus 2 because the bottom had a factorial symbol, right? And it equals 42. Then the n minus 2 factorials can cancel. And I'm left with n minus 1 equals 42. What do I do next when I have something like this? This is grade 11. We're using quadratics from grade 11. Yeah, we're going to distribute that n in. So we're going to distribute the n in, and we're going to get n squared minus n equals 42. The difference between grade 10 and grade 11 was quadratics and linear equations. When you had linear equations in grade 10, your full goal was to get the variable by itself. And then you just could solve for it, right? With quadratics, you could never get the variable by itself. One of them is squared and one of them is not, right? So what was your first step always with quadratics? Move it all to one side and set it equal to 0 every single time, because you can't solve for just one variable. One has a squared on it, one doesn't. They're not like terms. So with quadratics, you always have to get to one side that equal to 0. So I'm going to subtract that 42 over. So I'm going to get n squared minus n minus 42 equals 0. going to factor. If you forget how to factor, you can always come in and ask questions, okay, if you forget how to factor. But what we do when we factor is we say, this has a 1 in front of it, so we can go directly to 2 brackets. When there's a 1 in front, we can put an n in front of both. How do we get these back 2 numbers, though? So when there's a 1 in front of the n squared, we can go right to n. How do we get the back 2 numbers? We always say what multiplies to give me the outsides and adds to give me the inside. So it's going to be what times what equals 1 times negative 42, so negative 42. And what plus what equals my middle term, negative 1. So I always write it out like this so I don't mess up. So what times what equals negative 42, what plus what equals negative 1. What's it going to be? Yep. 7 and 6. Yeah. And which one has to be positive, Andrew, in order to get the... Yeah, 6 has to be positive, and the 7 has to be negative. Exactly, because we need to get a negative 1. Right? So we're going to put a negative on the 7 to get a negative 42, and a negative on the 7 to get a negative 1. So I always write it out like this. I know it's long and foolish, but then I don't make equals, because I can double check myself. Yep. Yep. Okay? Now I can go right to my blanks, and I can go negative 7, positive 6. So really this lesson in quadratics in grade 11 was really just grade 10 with a tiny little bit of extra. What was it? We had to get everything to one side set equal to 0, and then we had to do grade 10 math, right? And then we had that one last step where we had to take both factors and set them equal to 0. So we have this equals 0 and this equals 0. So we have n minus 7 equals 0, n plus 6 equals 0. This one we're going to add 7. N equals 7. This one we're going to subtract 6. N equals negative 6. Now this is the key thing. We can't get 2 solutions. We're going to get 1. And in this case we're going to get 1 because one of these is negative. And why won't a negative work here? What should you actually always do when we just solved, right? We found out what a variable equals. That's the word. When it says solve, doesn't matter what math course you're in, if the word solve comes up, ultimately in the end you need to have variable equals number and box it, right? That's what we're looking for. Whenever we see solve somewhere, we can go right to the end of your question and see, did they do algebra? Do they have an answer box? Because you need to know what the variable equals. That's what solve means, right? So when you solve, you should always check your answer to make sure it actually works, because they gave you an equation in order to solve. You need an equation in order to solve. That's what has to happen. So whenever you're given an equation, the great thing about equations is you can always check your answer and walk away knowing you're right, or walk away being sad. Those are your 2 options, right? You plug it in, you got it, or you plug it in and it just doesn't work, you try again. So if I put 7 back in, I get 7 factorial over 5 factorial. We agree? If I go 7 factorial divided by 5 factorial, I get 42. It works, right? So I'm happy. I walk away. I know that's a good answer. Why doesn't negative 6 work? Can you do negative 6 factorial? Can you do a negative factorial? No, remember I told you start at a number and you go to 1. You can't have zeros, you can't have negatives. So negative 6 factorial can't even work. So what do? You box this one to show that it's correct. N equals 7. And you circle this one and put a line through it and say extraneous. That means it is a solution, but it does not work. And they're going to look for extraneous, you showing that it doesn't work. Okay? So one worked, one didn't. Why in the heck are we doing this? We're doing this because there's this permutation formula here. You probably don't have it. Do you have it? I thought you didn't have the other ones in the rewrite for last minute. So, It's NPR, the N and the R are subscripts, equals N factorial over N minus R factorial. So that's a formula. That's a permutation formula, which we're going to start talking about permutations tomorrow. So it's when you take a certain amount of things, N has to be, R has to be less than N, because you might be like, hey, I have 6 people, and I'm picking them, 3 of them to be part of the group. So it would be 6p3, which we're going to learn about, which we haven't learned about. What I need you to know is, we need to be able to do this so that when I get you this formula tomorrow, you can actually use it. Okay? So that's the formula. If you look, it looks a lot like this, doesn't it? This equals a total, correct? Well, this would equal a total amount. It's the same thing. Okay. So we're going to go here. We're going to come back to example 4, but we're going to do it tomorrow. I just have it here because I want to come back tomorrow to do a long-handed permutation question. Okay? So we're just going to we're going to come back. We're not going to do that one right now. So algebraically solve this equation. So say you were given this equation. It is n minus 1 p2 equals 90. N minus 1 p2 equals 90. The only thing you can do with that is put it into the formula. The formula is this. NPR equals n factorial over n minus r factorial. Okay? So technically, this is NPR. This is n, and this is r, right? And then it just equals 90, which we'll do after. So we can plug this in for n, right? And we can plug this in for the r of this formula. That's what that states. So I'm just going to do this over here. N minus 1 p2 equals 90. And then I'm going to fill this in. I'm going to fill n minus 1 in for the ends of this formula. So I'm going to get n minus 1 factorial. So I just filled it in for the n here, right? Divided by, and I'm going to fill it in for this n. Instead of n here, I'm going to fill in n minus 1. N minus 1 minus sign, right? The r, and the r is a 2. Bracket factorial. So I literally just filled this in for the n and this in for the r of this formula. And it's going to equal 90. So instead of writing the n minus 1 p2, I could write it in this formula. Because that's what it says I can do. Okay? Yeah. Yeah. So I'm going to get n minus 1 factorial on the top over n minus 3 factorial on the bottom equals 90. Because n minus 1 minus 2 is 3, right? Which one's bigger, n minus 1 or n minus 3? Which one's bigger? N minus 1? Because if I fill the number in like a 6, 6 minus 1 is 5, 6 minus 3 is 3, right? So it's going to be n minus 1. So when it's minus, it's actually backwards. The smaller one is bigger. And when it's pluses, the bigger one is bigger. So we're going to get n minus 1, n minus 2, n minus 3 factorial. And I'm going to stop there because the bottom is n minus 3 factorial. Equals 90. Then my n minus 3 factorials can cancel, right? We're back to that same question we had before. That's the other. So now I'm going to get n minus 1 times n minus 2 equals 90. What must I do next? Expand. So I can FOIL, or distribute if you don't like calling it FOIL. But I'm going to go first times first. Because whenever you have a binomial times a binomial, 2 terms times 2 terms, you FOIL. So you're going to get n squared. And then outside, n times negative 2 is negative 2n. Negative 1 times n, inside, negative 1n. Negative 1 times negative 2 is positive 2, equals 90. I'm going to get n squared minus 3n plus 2 equals 90. Now, some people will try and factor from here. They'll go, what times what gets me 2, and what plus what gets me negative 3. I can never go, what times what gets me what, and what plus what gets me what, if it's not equal to 0. If I do not have it, that was the biggest thing you were taught in grade 11. If it is not equal to 0, I can do nothing. Okay? So what do I have to do first before I even try and factor that? Yeah, minus that 90 over. Get that equal to 0. So I'm going to get n squared minus 3n minus 88 equals 0. And because I have a 1 in front of that n squared, oops, I moved that somehow. I don't know. And then I'm going to get an n, a bracket, an n, bracket equals 0. And I can do that because I have this positive 1 in front, right? And I'm going to say what times what equals the outsides, so negative 88. 1 times negative 88 is negative 88. And what plus what equals the inside, minus 3. So multiplies to be negative 88 and adds to me 3. Yes. Negative 11 and positive 8. So now I can go n minus 11, n plus 8. And then I can solve them each separately. N minus 11 equals 0. N plus 8 equals 0. Add 11. N equals 11. Subtract 8. N equals negative 8. What do we do then? We could check it, and I'll show you how. So this is n minus 1 p2, right? So it would be n minus 1 p2 equals 90. And I'm saying 11 would work, right? So I'm going to go 11 minus 1 p2 equals 90. 11 minus 1 is 10. 10 p2 equals 90. That's what I'm saying, correct? Do you remember seeing that, like, something p something button somewhere, anywhere? It's very close to the factorial. It's the same spot. I told you use 2, 3, and 4. So we're going to go 10p2 into our calculator and hope it's 90. 10. Now I'm going to press math. I'm going to arrow over to probability just like I did for factorial. And I'm going to pick number 2. And then it was 10p2, I think, right? Boom. We know we got it right. This is 90. We plugged it back into the original. That's the great thing about solving. When everyone hates solving, I'm like, I love solving. I know I can walk away happy or sad, at least. So I know I got it right or I didn't. So this one's good. What's about negative 8? It doesn't work. Because if I plugged it in, it would be negative 9p2. Plug it into my calculator, it's an error. So I circle cross through it and I say extraneous. So I somehow moved these over. So your homework is going to be numbers 1, Number 2. Can you look at B for a second? We have always done everything where we had factorial over factorial equals something, correct? If we look at B currently, is B factorial over factorial equals something? No? Can we do something to it to make it that way? What could we do? Divide by what? Yeah, divide by the brackets that are stuck by it. That's it. So we can go and cross that off, right? So sad. Why does it ruin my life? I'm going to write them on the whiteboard, and then you'll be able to see them if I write them really big. Okay? Does it have the answers at the end at least? Did that print? Okay, thank goodness. Okay, so I just want you to do numbers 1 and 2 anyways, so I'll just write them on the board.